This is the Algebra 2, Unit 6 review. Starting with question 1, draw a circle around each equation or graph that represents a radical function below. There will be more than one correct answer. So I'm looking for a radical function, and I know when I see that radical that I'm looking for something that looks like that or something equivalent. So let's take a look. Okay, I see that this one's a radical function. This one's a radical function. This one's a radical function. All right, if we look at the graphs, I see that this one's radical because it's square root, and then this one is also radical. Be very careful with these two. This one's cubic, this one's quadratic. If you're not sure what the actual graph looks like, you could always put the parent function into the calculator to be sure. So go into y equals, and let's do the square root of x. I'm going to take a look and see what that looks like. Okay, so it kind of looks similar to this guy right here, except it's a reflection. And then we can do the cube root. Remember, cube root is in the math button, so math. And then down here is cube root. So the cube root of x, and let's take a look at what that looks like. And I see the parent function looks similar to that one. Now there's one more we want to check here. That's a little deceiving, is this one right here. Okay, if you remember from class, we can write, we can change from radical form to exponential form. So this would be equivalent to -2 7th root of x cubed. So that one's also a radical function. Okay. All right, let's look down number 2 and 3. Number 2 and 3 list all the transformations from the parent radical function into the transformed function. Okay, so you remember that you have the generic f of x equals plus or minus a, and then radical x plus or minus h, and then outside the radical plus or minus k. And each of these means something. Remember, k is up and down, h is left or right, but we have insiders lie, so left is actually positive. A is a vertical stretch or compression, and then the negative out in front is going to be reflection over x. Okay. I went fast through that because we've been through this 1,000 times, so let's take a look. All right, the 4 out in front is going to be a vertical stretch. So a vertical stretch of 4. That's this one right here. All right, the 17 over here means up 17. And then the minus 32, insider's lie, says that that means to the right 32. All right, let's take a look at the next one. All right, the negative over up front means a reflection over x. X-axis. Negative 36 back here means down 36. And then we have inside plus 18, which means insider's lie, to the left 18. Okay, so each of those things are just telling you what the transformation is. Let's take a look at the next one. State the transformation from the parent function of the radical function given. Then graph the parent function and the transformed function on the coordinate plane provided. Okay, so let's first remember our parent function. This is going to be square root, so our parent function for the square root looks like this. All right, and you can actually go into the table and we could get some points to plot here. I'm going to plot my parent function in purple. So 0, 0, 1, 1, 4, 2. So my parent function looks like this. Okay, so that was my parent function. Alright, now let's look at our transformed function. So that negative in front means a reflection over the x-axis. Okay, so that means now that I'm going to be going down this way, and then I have plus 2 on the inside, so that plus 2 means to the left 2, and then the minus 3 means down 3. Now you could put this in your calculator, but you could also graph it just by using that information. So I know that I'm going to be reflecting over the x-axis. I'm going to the left 2, 1, 2, and down 3, 1, 2, 3. So here, and then here, here. Okay, and there are my two graph functions. Also, if you go ahead and put that in the calculator, put my parent function and then the transform function, and look at the graph, you can make sure that you've done it correctly. All right, let's do the same thing with the next one. Notice the next one is the cube root function. So cube root, let's take a look to see what happens. Again, it wants us to graph the parent function and then the transform function. So let's go ahead and put the parent function in here. Alright, I went ahead and I put that into the calculator, went to my table, found a few points to plot, and then sketched my parent function. So there's my parent function. Now we're going to take a look here. I have the minus 3 on the outside, which means, or I'm sorry, minus 3 on the inside, which means that means to the right 3. And then the plus 1 means up 1. Now these are a little trickier, but basically you're going to focus here on this point. Let's do this in red. Okay, and this is where it's going to go to the right 3, 1, 2, 3. Okay, and then it's going to go up 1. So this is my starting point here. Right, and then I know that I'm going to be here, and then it's going to gradually go up. Okay, and then I graphed my transform function in red. It's a little ugly, but and you can go ahead and put that into y equals. And remember, to get to the cube root, you have to go into the math function. That's number 4 for your cube root. And then you can graph it, and you can see what it looks like. So there's my parent function, and then it graphs my transform function to make sure that you've done it correctly. So you should be able to do it without your calculator, but definitely double check in the calculator to make sure it looks correct. Okay, moving on to page 2, number 6. Consider a transformation to the parent function f of x equals the square root of x. The transformation is described below. Draw the parent function and the transform function and write the equation. Okay, so this is kind of what we were doing before, but now we're doing it kind of the other way. All right, so go ahead and graph your parent function and the transform function. Got our parent function. Again, you can put it in the calculator if you're not sure. And then here it says reflected downward. Okay, so I know that, remember, my parent function starts at 0, 0. I'm going to reflect downward. And then a shift up 2, so 1, 2. And then a shift to the left 4. 1, 2, 3, 4. Okay, so there's my starting point. Just like I went over 1, up 1, and then I went over 4, up 2, I'm going to do the same thing. So, but remember, we're going to be facing down. It's a little better than mine. So there's our transform function, so then the resulting equation. So I have f of x equals, I know this is the square root, because they told me that that was my parent function, so that's where I'm going to start. Reflection downward, which is a reflection across the x-axis, I know means a negative in front. And then a shift up 2 units. Up is on the outside. So remember, we're going back to this. This is without any shifts, and so that I'm making the adjustments to each part. So up 2 would be my K, which is on the outside, and then left 4, which would be my H on the inside. But left, remember, insiders lie, so that would be +4. Make sure that your radical is over top of the x plus 4, and then on the outside, shift up 2, which would be +2. So there's your equation. All right, let's go on to number 7. What is the range of f of x equals the square root of x plus 2 minus 5 if the domain is the set of all real numbers? Write your answer in interval notation. Okay. So if you don't know right off the bat what the answer is going to be, my suggestion would be to put this in the calculator so you could see the picture. Okay. All right, so I went ahead and put this in here. Just be careful when you're entering this that when you get to the +2, you arrow out, because you want that -5 to be on the outside of the radical. So then we're going to graph. So I see that this graph, I want to know the range. So the very first value of the range is going to be -5, and then it goes to +infinity. And you should be able to tell this by this as well, because this -5 is a shift in y, so that's down 5. And then interval notation, I'm going to have a square bracket, -5 to +infinity. All right, next one, what is the range of f of x equals the cube root of x minus 2 plus 6 if the domain is a set of all real numbers? Well, I know already that it's -infinity to +infinity because it's the cube root, but if you want to go ahead and put in your calculator, remember math, cube root, x minus 2, arrow out, +6, graph. So -infinity to +infinity. All right, and then the next one's same thing, except this one wants the domain and the range. So you can put that in your calculator, or look at the transformation to be able to tell what the domain and range is. Okay, so for the domain, I know that this -5 means I went to the right 5, so that's going to be my first value of the domain. So 5, 2. And then that goes on forever to the right, so +infinity. In the range, that +3 means I went up 3. So my first value of the range is 3, and that's going to keep going up, so that's going to also go to +infinity. Okay, and then cube root function, domain and range. So again, you can put this in your calculator, but the domain and range for odd function almost always is -infinity to +infinity, with just a few exceptions. But you could put that in your calculator and see that as well. All right, number 11. On the given coordinate axis, draw the graph that fits the following conclusion. Okay, so we might have some variations here on the answers, but is the graph a square root function? Okay, so we're going to go back up here and remember that our square root function looks like this. So it has that end point and it goes in one direction forever. The domain, okay, so the domain is -2 to infinity, which means that I know that I start over here. Okay, and then the range is -infinity to +4. So that means that my starting point has to be here. Okay. And because the range is -infinity, I know that it's going down. So I know that my graph has to look something like this. Okay? And then the equation, so I would have f of x equals, because I'm downward facing, I know I have a negative in front, square root of x. I went to the left 2, so that's +2. And on the outside of the radical, I went up 4, so +4. So these are all very similar. It's just a different way of asking the question. Okay, next one. Okay, the next one says on the given it, given coordinate axis, draw a graph that fits the following conditions. So it is a cube root function. So remember, cube root functions look like this one that we did for number 5. Again, if you don't know, put it in the calculator, but remember cube root. Okay, so cube root is going to be f of x equals the cube root, so it looks like that. Okay, or at least that's the start of it. So cube root function, and then it says goes through the point 2, -1. So remember, on our cube root, we're starting at the origin for our parent function, and then 2, -1 is x and y. So 2, but remember insiders lie when we're looking at our equation, means that I'm going to go to the left 2. -1 is a change in y, which means I'm going to go down 1. So right there is going to be my new starting point. And then you can draw in the rest of your graph. I have the 2, -1, so for my equation, that 2 is going to be x plus 2, because I went to the left 2, and -1 because I went down 1, so -1. So that would be an example of my equation. All right, let's go on to the next page in this video. All right, so give the graphical characteristics for the function pictured in the graph. So we've done this a ton of times. So let's go through this now. All right, so looking at the picture on the left, okay, we know that this is, by the shape, we can tell that this is a cube root function. Okay, so the parent equation is f of x equals the cube root of x. Domain, okay, from left to right. Remember, even though it doesn't show on this graph, there are arrows on here. So -infinity to +infinity. Range, down to up. Even though this does seem like it's slowing down, it does go down to -infinity and then up to +infinity. Zeros, so I have it right here where it's crossing the x-axis. So x equals 1. Written as an x-intercept, we write that as 1, 0. All right, and then we have the y-intercept. Okay, so my y-intercept right here. So let's say that's at about 0, -0.3. Increasing interval, so if I'm starting over here, this graph is always increasing. Imagine if you're on the roller coaster. It's going up, up. It goes up really fast, but then it continues to go up. There's no place where this decreases. So my increasing interval is from -infinity to +infinity. And then there's no decreasing. Remember, do not leave that blank. If it's not decreasing, then you put none or NA. Either is acceptable. Local maximum, there's no maximum. Remember, we define maximum as a turning point where it goes from increasing to decreasing or decreasing to increasing. It's increasing the entire way. Asymptotes, no, there's none of those. And in behavior. So as x approaches infinity, so right here, as x approaches infinity, where is f of x or y going? That's going to infinity. And then as x approaches -infinity, where is y going? It's going down, so it's going to -infinity. All right, let's take a look at the next one. Give the graphical characteristics. Okay, I know that this is a square root function. And I know that my parent equation of f of x equals the square root of x. If you're not sure, put them in the parent functions in the calculator so you can be sure. All right, we know that even though this is kind of hard to see in this graph, we know that by definition of square root is going to have a starting point and then it's going to go on forever in one direction. So I'm going to go ahead and put those onto my graph. Domain, so for the domain I'm starting on the left. There's nothing over here to the left. So my first value for x is at -2 and there is a starting point or an end point there. So -2 and I'm continue on from left to right, so I know that goes to infinity. Range, I'm going to start down here. Notice there's no values down here. All right, my first value is -1. and then the graph keeps going up, so that's going to go to positive infinity. All right, and then we have zeros. So remember, zeros where it crosses the x-axis right here. So x equals -1. And written as an x-intercept, we have -1, 0. Okay, and then the y-intercept. So the y-intercept is right here. Okay, so that y-intercept is going to be 0, 0.4. Another good thing to do would be to label this endpoint what the value is, because that will help you with your domain and range if you didn't see that. So I know that that starting point is -2, -1. Remember, this is x, y. So that's why it corresponds directly to our domain and range. All right, increasing and decreasing intervals. Notice again, if I start here, this graph continues to increase the entire way. So I'm increasing. Now the starting point of the increase is at -2. So I'm increasing from -2 to infinity. There's no place where there's any decrease. There's no change in direction. There's no asymptotes. Okay, and then we have as x approaches infinity, f of x approaches positive infinity as well. And we don't talk about the end behavior on the other side because we have a definite endpoint there. So you wouldn't answer that question, so you can scribble that one out. That's the end of this video.